All right, so conics. We have worked with circles, ellipses, hyperbolas, and we started parabolas on Friday. What's our basic circle equation that's been translated? All right, we don't want the little one and then the big one. Let's just use the big formula. Translated circle. What does it look like? Okay, so in this case, what does the H and K represent? The center. What does R represent? The radius, okay? Then we shifted to ellipses, and it was similar, right? What was different about a circle when we made it squashed into an ellipse? Okay, so we still had the x minus h quantity squared, we still had the plus y minus k quantity squared, but instead of having the r squared on its own side, that got divided over, right? And there would have been numbers here and here that when you divide that r squared over, it gives you different values for a and b, okay? So it's not a nice circle with a consistent radius. It's longer on one side than the other. So we have an a squared and a b squared here, and it equals 1. Okay, so in this case, what does the h and k stand for? Center again. What does a stand for? And I get that answer a lot. A is not your vertex. If I said A is 5, you're not going to say my vertex is 5, right? What is A really giving you? The distance from center out to a vertex, yes? So your A, B's, and C's are lengths, right? They're distances. A gets you to your vertex, but it isn't the vertex. Does that make sense? Okay. So A is the distance that takes you from the center out to a vertex. B is distance from center to covertex. And then what about C? Center to foci. And what's the relationship between A, B, and C in an ellipse? Okay, so we said if there's a plus here, there's a minus here. Yes? All right. How do we know when looking at our equation? Well, let me back up and ask another question first. What can switch in this one? The A and B. Okay, so we have another version of this where the b squared is first. Okay, so how do we know when we look at an equation that just has numbers in there, how do we know which one's A? A is always bigger. Okay, then we shifted to hyperbolas. What changed? It was a similar equation, right? What's different? The sign changes. So we had x minus h quantity squared minus y minus k squared. Yes? What went under the x minus h piece? A squared, b squared, and it equals 1 still. What flip-flops in this one? The top. Okay? So how do we know when looking at it which one's A? Because it's the first one. And then we look, is it paired with an X or a Y? Okay? And what is the relationship between A, B, and C in a hyperbola? Okay, so again, if there's a minus here, there's a plus there. Yes? Okay. A, B, and C, do they stand for the same thing in a hyperbola as they do in an ellipse? Is A the distance from center to vertex? Yes. Is C the distance from center to focus? Yes. What's the slight difference? Yeah. B is the center out to the other side of that box, right? It's not labeled anything because our hyperbola branches don't touch it at all. It's not a point on our graph. It's just there to help us make the box. And then how do we write the asymptotes? Okay, so it's kind of that y equals mx plus b version, right? We need to know the slope, and we can get the slope right from our box. Rise over run. Okay. So we shifted on Friday to that last conic, the parabola. And the equation was a little different. All of these are very similar. Slight little changes, change it from one conic to another. But the parabola was, there were several things different about it. What did our basic equation look like? I know we haven't translated them, but what's the basic one look like? Okay, we had x squared equals, 4py, or, okay. So, couple things that are different. Only one of the variables is squared. Here we have x squared, but the y isn't. In the second one, we have y being squared, but the x isn't. That's your clue that it's a parabola. Okay? There shouldn't be any question about which ones are parabolas, because you only have one squared variable. What does the p stand for? We've had lots of work with a, b's, and c's, but this is the only equation that has a p in it. And that first term in the definition you gave me is critical. The directed distance. This is the only distance piece that can be negative. All right, they're giving you a hint. Is this opening up, down, left, right, based on whether it's a positive or negative value for p? It's a directed distance, so it has to go from vertex to focus, and that direction is going to clue you in on which way it opens. Okay, so what we're going to do today is we're going to take this x and turn it into, what do you think? X minus an h. And we're going to change the y into y minus k. Okay, so we're going to translate them just like we have been doing all the other ones. The one other thing to point out, what did the h and k stand for in circles, ellipses, and hyperbolas? H and k, you view your center, right? And then you based your a, b, and c measurements from that point. Here, what does h and k represent? The vertex, right? The parabola is the only shape that we don't call it a center. It's the vertex, just like it's kind of like the vertex on an ellipse, okay, that far point. All right, let's look at our equations. First one, we've got a parabola that says vertex is at hk. We've got our two translated versions. The first one is listed as a y squared, which means it opens which way? The y squareds are to the side, left and right. Okay. The x squareds open up or down. And again, we can decide that based on is p a positive or a negative value. Just a reminder, the directrix and the focus are based off of that vertex, not the center. Okay, let's try one. It says, list the vertex, focus, and directrix of the parabola and graph it. So first thing I look at, do I have an x squared or a y squared? I have an x squared. If it's an x squared kind, it tells me that I'm either up or down. X squareds go up or down. Next thing I look for is, what is the value for p? How do I find that? Okay, this 8 right here, right, is taking the place of that 4p in our equation. So we have 4p equals 8. That means p has to equal 2. And because p comes out as a positive value, which way is this going to open? Up. Okay. Next thing I look for, my vertex, because I have to base all these measurements off my vertex. So from my equation, what is the vertex? Good. All right, so let's sketch what we know. We have a vertex at 3, -1. We're going to label that with a V. We know it opens up from there. And we know that P is 2. So where does my focus land? I have to go from the vertex up 2, right? We said it opens up. So up 2 puts it here. What are the coordinates of the focus? 3, 1. Okay. And if the focus is 2 above the vertex, where is the directrix? 2 below. Okay. So we go 2 up to get our focus. We're going to go 2 down to get our directrix. Now remember, the directrix is not a point. It is a line. Okay. What's the equation for that line? Y equals -3. Okay. So we've identified the vertex, the focus, and the directrix. Yes? We've got our graph almost finished. How do we find those other points on the parabola to figure out how wide to make it? Well, 8 equals 4p, right? P was 2. So 8 is what we call the focal length, all right? The length of the chord through the focus with the endpoints on the parabola. So because it's symmetric, we're going to split that 8 into 2 parts. So on either side, we're going to go 4 spaces. So from the focus, I'm going to go left and right 4 spaces. And that whole length there from these 2 points that I've marked with an X, that's my focal length, okay? It has a length of 8. And then I know how wide I need to make that graph. You will be expected on graphs of parabolas to list a focus, a vertex, a directrix, and to have those other 2 points graphed so you know how wide it is. Okay? All right, let's try another one. I'm going to pause the video on this one, let you try it at your tables. Do we have x squared or y squared? Y squared tells me what? What? Okay, so it's going to open left or right. And then can we figure out p from our equation? Okay, so 4p is -12. So p has to equal -3, which means it opens left. Okay, how about vertex? Can we tell that from the equation? Yeah, did anybody have them turned around? It should be -2, -4. Make sure you put in your h value and then your k value, right? Okay, so vertex, -2, -4. And we said the focus is going to go which way? Left, how many spaces? 3. So it's a directed distance, a -3. We're going in the negative direction, 3 spaces. All right, there's my focus. Where would my directrix be? 3 on the other side. Okay, so coordinates for focus are what? -5, -4. Okay, and equation for directrix? Okay, agree with that so far? All right, now, how wide is the focal length? 12. Don't worry about the negative. That just helped us get which direction it was going, right? The distance is 12. We cut it in half, so we're going to go 6 from either side, right, of that focus. So it's a pretty wide parabola. Yes? All right. The next set, we're doing the reverse. I'm giving you some details about the parabola, and you're going to write the equation. Okay? So first one, I would sketch it out. It's much easier to tell once you've looked at it. 3, -2 is the vertex, and the focus is 5, -2. So from that information, I get several things. What do I know? I know h and k, they already gave me that, right? But from graphing it, what have I figured out? It's a y kind, right? The y squared, because it's opening sideways. Which way is it opening? It's going to the right. I know that because my vertex, or my parabola curves around the focus. Yes? So I know that it's a y squared kind. And what is the value for p? That directed distance from vertex to focus. How far did we go? We went 2 spaces in which direction? Positive or negative? In a positive direction. So p is a 2. Yes? And that's all I need to write my equation. We said it's a y squared kind. Right? So y minus k equals 4p times x minus h. And let's plug in what we know. We know p is 2. So what am I going to have here in front? An 8. X minus, what's the h coordinate? 3. And k is negative 2. So minus a negative 2 would be plus 2. We good with that? Yes or no? Okay. What about B over here on the right side? This time I'm giving you a focus and a directrix. All right, so picture your focus is at negative 4, up 5. My directrix is y equals negative 1. What does that tell me? It has to open up because it's not going to hit the directrix at all, right? Does it also tell me which way or where the vertex is? If I know a focus and a directrix, where would the vertex be in relation to those two? Where? Right in the middle, right? Right in between them. So how far apart is it from the focus to the directrix? How many spaces? Total spaces from focus to directrix. 6. So if I cut it in half, 3 spaces from either side, gets me to my middle. That's my vertex. So what's my h and k value? What is it? What are the coordinates of my vertex? Okay. What is p? P is 3. Directed distance from vertex to focus. To go from here to here, I had to go up 3. So P is a positive 3. All right, so what's my equation going to look like? Which one is squared? Okay, it is opening up, so it's an x squared kind. So x minus, it's going to end up being x plus 4, yep, equals 4 times P would be 12. And then our y minus k, y minus 2. Yes, no? All right, try C on your own. Looking at what we're given, 2, 3 is my vertex. And directrix is over here at negative 4. All right, so how far is it from vertex to directrix? It's 6 spaces. And if it's 6 spaces here, then it's also 6 spaces this way to get to my focus. Yes? Which tells me that P has to equal 6. And I went from vertex in a positive direction to get to my focus, right? So P is a positive 6. Yes? They gave me H and K. We just found P to be 6. That's all we need for our equation. Oh, I guess we do need to know, is it x squared or y squared? How do we know it's a y squared? It's curving off to the right, right? It's opening to the right. Okay, so it's y squared. All right, what is 4p going to give us? 4p would be 24. And then our vertex, our x coordinate is a 2, our y coordinate is a 3. Yes? All right. The last one we're going to look at. I'm going to back up a second and give you a couple applications of where you might see a parabola in the real world. Okay? Something on a car. Anything come to mind? On the front of a car. You use them at night. Headlights. Headlights have a parabolic mirror as the back of it. Okay? And where the focus is where the light bulb is placed. Because one of the characteristics of a parabola is that anything, light, sound, whatever, anything emitted from the focus is going to bounce off the back of that parabola and shoot straight out parallel to the axis of symmetry. So if you put a light bulb at the focus, all of that light is going to bounce off the mirror and go straight out. Okay? That's how all the light shines ahead of you. Now, we could turn this upright and make a microphone out of it. Okay? It's used to record things like on the sidelines of a football game. Okay? So picture a parabola like this now. Okay? Here's your focus. We're going to put a microphone there. So all the sound is going to come in and just do the reverse of what the headlight did. All the sound is going to come in, bounce off of that back parabola shape, and go to the focus. So it's going to take all that sound and concentrate it at the microphone. Okay? So that's the first one we're going to look at here. We've been working with translated parabolas where the vertex is not at the origin. However, if you can sketch it so it is at the origin, it just makes your equation much easier. Right? You don't have to worry about having an H and a K in there. So it says an engineer is designing a parabolic microphone. The design is for the bowl to be 8 inches wide and 2 inches deep. Find the equation for the parabola used to shape the microphone, and at what point should the receiver be placed relative to the vertex? Well, remember that sound all has to get concentrated where? At the focus. So we're going to put the receiver at the focus. Okay? We are going to place that parabola so its vertex is here at the origin. Okay? It's just going to make it a lot easier. Now, they have cut off the general parabola, right? It doesn't keep going forever. They've given us some dimensions for it. They've said we want this parabola bowl to be how wide? 8 inches. And we want it to be how deep? 2. So from here to here is 2 inches. Okay, so we're going to place the vertex at the origin. And can you tell me the coordinates of this point? Based on how I've laid it on the coordinate axes there. If the whole width is 8, we split it in half, right? So we have the point 4, 2 over here. Agree with that? All right. Is it going to be x squared or y squared based on how we drew it? It's an x squared. Okay, so x squared equals 4py. We said we don't have to worry about an h and a k because we put it at the origin. We don't know p yet, but we know a point that has to work on the graph, okay, that has to fit the equation. This point 4, 2 has to work. So if we put a 4 in for x and we put a 2 in for y, the equation has to work. Yes? Yes? No? Okay. Simplifying, we've got 16 equals 8p, so p equals 2, okay? Can we write our equation? All right. We said x squared equals 4py. If we put a 2 in there, x squared equals 8y. And where should they put the receiver? Coordinates based on what we graphed would be the point 0, 2. Okay? I'm going to say it's 2 inches above the vertex. Okay? For our purposes, that would be the coordinate 0, 2, but again, if they shifted this to a different vertex, it still would be 2 inches above. Okay? Now, some of you might be looking at that and saying, well, we kind of knew that already. Right? They gave us 8. However, you have to be really careful because they did not say that 8 was the focal length. It happened to work out that way on this one, but it doesn't have to. I could make a headlight, okay, and I could give you how wide that headlight is. That does not mean the focus is in line with the edge of that headlight, right? The light bulb is not on the outer edge of your headlight. It's back in here somewhere, okay? So just because in that particular example, our focus landed right on that focal length, that focal chord, okay, doesn't mean it's always going to be that way. So you have to find some point, like this 0.42, that works and back up and figure out what P has to be. Okay? All right. You guys are going to do 26 to 42 evens and then 62, 63, 66, and 67.